Well, thank you to Mr. Carlos. This is an important effort to incorporate these technologies to a subject of such importance for our brothers and sisters in Tabasco. Every year they get floods. So let's pass to our Q&A session. Hopefully there will be many since we didn't have the discussion by at the beginning. Well, there is double time for questions and answers. So we have a question from Elena of the UNAM. She asks, was this technology used to detect lutite mines in northern Mexico? This is for Mr. Fabian Garcia Nocetti. Yes, this technology has been developed for those assets in southeast Mexico. But yes, similar technologies are used in other areas as well. The difference has to do with the type of terrain, but the availability of seismic information. So there is, of course, we have seismic profiles, and that's where it's convenient to conduct this type of development with this type of technology and methodology. But on other occasions, what we have is information on petrophysics, and this requires another type of technology. So there's something I'd like to mention. Well, the methods presented by Dr. Fabian on neural networks are used for many things, and it's one of these phenomena we're seeing now. The tools which are currently in use and which have a high spectrum of applications in different fields. For instance, these neural networks showed by Dr. Fabian, I've used them for demographic analysis, for intiometric analysis, economic analysis, and now to do geophysical analysis. And it's the same technique, the same algorithm, but it's been used, or it can be used for a diversity of applications. Any other questions? Yes, if you could please identify yourself. I'm Ariel Juarez from the Ministry of Tourism. At the Ministry of Tourism, we are currently implementing the use of information tools from official but also unofficial sources. We've been trying to find within the government how to use this information, see what the reach can be for it. As Ronald said, there's great potential for big data. Let me just tell you briefly, Visa came to us to request help to use the calculation of the data through taxes, but now we have thousands of units of data to see how much is spent per credit card, and also we extrapolate the amount of money that people withdraw from an ATM. So this is an example of INEGI to exploit Twitter information to learn more about flows, and this goes in the sense of, as Fabian said, we're trying to break with the paradigm of using information from unofficial sources that are not open, or it's done through many limits. They break with rules but we need this information for decision making. And the government, on the other hand, we have the barrier when it comes to use of this information. We can use it for internal but not for obtaining non-official data from non-official sources, say how something is behaving. So my question, what do we need to do to break with these barriers that are falling, and that within the government we're trying to create synergies or mergers to make better decisions? I can tell you a bit of the case of Global Pulse. The use of information as cell phone consumption is always very, very delicate, and it will be hard for a company to actually give you their numbers, but an alliance with a laboratory such as Global Pulse at the UN can be um, well, great help, but that perhaps they're not available, but their public can be a good example. But say the use of this data and these sources, sometimes it's different. It's difficult for the owners of information to want to share this, when it comes to this type of information. So what we're trying to do is, for those of you who participate, the coordination launched a contest called Dataton, which is on dataton.gov.mx, and Telefonica and the municipality of Zapopan open federal sources, open data, and we made a call to um, a contest for data analysis and policy improvement. What for? To bring to permeate data into decision making, and to have better examples to say how information, which a few years ago could only good be, the only good I could do was to be a better sales target, or what your cell phone is selling you can do something like this. So Dataton is an effort that we're making to show the data and have it flow better. I I think this is easy for me to answer because I'm less involved in public policy. But okay, Ronald said collaboration networks. That's important. It seems like a huge challenge, but institutions want to do everything, and this is going to be very difficult. Yes, um, the fact that we have these things to consider, it's a good thing. But if you have third parties who have created these networks and standards for data generation and data analysis that we well, maybe for an organism it can be a much more difficult thing. I applaud the digital strategy. Is well, they're saying that electronic government doesn't refer to compliance or transparency, it refers to efficiency. I hope that, well, in the future we're not going to be the messengers of the birth certificate, as was mentioned. There will be other sources of data within the government, and hopefully policy will give us access to data that's out of the government that could be complemented with Twitter and other sources of official and unofficial data generated by what we call citizen empowerment. And these projects would be a response to your concern at the Ministry of Tourism. And this is when we say that open data and open government must go from generating possibilities for entrepreneurship for society and collaboration, etc. Lalo Kenneth from Costa Rica, from INEC. My question has to do with well, the government has said that we have to use open data, but in the case of institutions, of semi-autonomous institutions that don't generate information, we generate services. We have difficulties or obstacles when it comes to implementing these and analyzing our information. Institutions that don't have the necessary people to do this processing or analysis in a swift way, the cloud as an option. How have institutions, how do you do it when you need to use the cloud but you don't have the necessary resources to implement these needs? Well, the cloud in this specific case is a reasonable option at a reasonable cost when you don't have the possibility of your own resources or a good cluster of computers with a large, well, an option of course is cloud computing. And without, and well, there are schemes that help this. So high, well, high performance computer architecture are not inscribed necessarily within having a cluster at home or institutions. We have the possibility of a cloud, and through different schemes of collaboration, this is it is currently a feasible way of beginning these issues. Definitely. Anything, anyone wants to add anything? I'm going to give you an example of what we did in this case. Well, although it may seem simple to say, okay, you have information, just to open it, it was a whole issue. We did face what you mentioned on the fact that some organizations don't have the infrastructure. Sometimes you have people who are technically trained but know nothing about open data. So it was about explaining what open data is, what generating a liaison. But there was an important project called the Data Squads, in which a person from our team, someone really technical called Rodolfo Williamion, and trained people trained in the use of data, people of Infotech, and someone from the legal department went and visited 10 organizations that decided to participate voluntarily in the training, and we showed them what open data was. We showed them how to create a portal to upload databases, and this process, even though Mexico is well, it's the 7th country to implement this. This had never been done. Normally, we would send a great number of manuals, and government organizations had to open them in other countries, and we decided to lead this hand in hand. ODI is documenting this, and the idea is that we replicate this in all the government agencies, and that it can be a government, a way in which the government can do this. At the Office of the Presidency, we can coordinate this. So it wouldn't be a bad idea if we did something similar, and that if you wanted to contact us, there would probably be people who would be happy to aid you in this. Just to add to this, the part on cloud computing, well, if you're starting from zero, from scratch, um, well, you should take privacy into consideration more than is currently being taken into account in Mexico. This has delayed the implementation of cloud in other countries. Cloud is cheap, it's scalable, it's better than nothing when you're starting from scratch. But when you want to upload official information, well, if the cloud is not in your country, you can't upload it, and then you have to define what can be, what can't, and what is the cloud. It can be Infotech, and it can be in Aguascalientes, it can be many different things. But today we're determining that you can't upload sensitive data to the cloud, whatever sensitive means, and anything that a general director says is sensitive will be defined by him, and that's being discussed. The second point, specifically when we refer to the cloud for big data solutions, well, we need to be careful of dependency levels. One is, what do you want the cloud for? To process data or to store it? If you want for both, the latency of the transportation of large volumes of data to process will be very expensive if you want, especially if you want to do real-time processing. Here we also have dependency on the supplier of the cloud, and particularly on the telecommunications provider. Uploading to cloud means that you've solved the issue of the efficiency and cost of telecommunications. Otherwise, the business case can be operational costs per areas can be okay, but having said this, when there's nothing, the best you can do is to start with a cloud. Just a question over in the back. Good afternoon. I'm Maria Angel Hawe. I'm director of topographic modeling of the INEGI. We've worked or we agree with what we mentioned this morning on policies, on defining what a policy is. Even though we have, we have big data, and the fact that we just add something to Excel, well, that creates data. But when it comes to big data, I would consider it two different environments: the geometry and the database, which nowadays we call it a geobase. However, we have an excellent opportunity to do what many countries have been doing, which is to define what kind of data and geometry we're trying to represent. We have 5 centimeter, 10 centimeter, or 2 centimeter um, rising, and it's only two. So they throw money to the garbage when there's a disaster between. We have Sedena, the Navy, the military. We purchase radar images for this situation. So what's most important, and I think, well, if we can establish a policy, what kind of data do we want as big data for Mexico? Because since the 70s, we've spoken of satellite imagery, creating databases, geodata. We need references, geographic references. All the all the registers are in 2D, except for New Zealand and a few countries. They're in these prints are in two dimensions. There's only 4 countries that have tried to have their information in 3 dimensions. So they give a permit to build a gas station, and it looks like like a like it's a plain, but it's actually a hill, and that leads to a mudslide. And there's territorial disorganization in Mexico as a result of, well, as we say in Mexico, when stormy waters, the fishermen win. So we need to determine what kind of data we need, because another organization out of Mexico is more important and are better at extracting information than the ones we have here. So it's important for me, from my point of view, to define what kind of data we have available, what CONAGUA wants, what Semarnat wants, what Senapred wants. Our example right now is Senapred, and it's the risk atlas with camera. I think we're duplicating our efforts in the case of Spain. They saved $30 billion, euros, I mean, by working together and saying, okay, these are the rules for data infrastructure. I think that's the first thing we need to do. What do we want to have as a data or geodata, notwithstanding whatever else? Thank you. This was a comment, more a comment than a question. Does anyone want to add to this? Any additional questions? I'm Mr. Copalma, and I want to thank you for your presence here. Then attest to what Mr. Castro said on the Open Data Squad. I was part of this at the Ministry of Public Education. And yes, it were 6 weeks of working on this. And soon we will be publishing it. But my question has to do with something different mentioned by Fabian Garcia. The figure of the data scientist, which should be incorporated at some point. The specific question is, where should we incorporate him and what level of the structure? Because we have the CEO, the CTO, so we need a CDO, because there are other elements that we need to discuss together with data scientists or mathematicians, programmers, DevOps, EBOps, ISOPs. So all them within what? Because there's a huge confusion, because between CIO and CEO there's a we had to clarify, one's more technological and the other one's more business, and now one in between the two, because it is no longer in programmer, because we probably don't understand them. A programmer usually doesn't know how to use Bayesian methods. A data scientist knows the statistics, statistician knows how to do it. So where would the figure, where would we need to bring this extra figure into the current structure?
Yes, well, that data scientist that receives information needs to be part of the research and development team as an interface between those that are designing the algorithms specifically and those that are programming in that regard. But it is very important that this concept, the figure of the data scientist, is well represented, because it is also a figure that does not naturally exist. It has been formed or adapted based on the needs. It is very important to highlight that currently postgraduate courses are being developed with this topic in mind, so that the profile of the data scientist and the curriculum associated to that, to the development they need, is of course suitable. But they work as an interface between the scientists that are developing the mathematical methodology and those that implement such algorithms to take them to programming. It is difficult at some point to define the, the, the limits or the boundaries, because it is possible to go from one side to the other. But what is actually important is to start thinking about the type of training, the type of experience that these data scientists should have, and the importance of their work as part of a team, as part of a research and development team in that regard. I'm going to answer very academically. Today, around 85 to 90% of big data analytical projects at companies go from business units. Usually it is the chief marketing officer or chief financial officers are those that develop this. CEOs are just starting to have, CIO are just starting to become part of these type of areas. That is serious because the data is being handled here under data, and the life cycle of data should be what governed this. This initiatives now discuss a multidiscipline profiles, and this should not be chief data science officers, but chief data officers that should have in their team very good statisticians, an expert on applied mathematics, and actuary for the unit of interest, because those that are studying customer behavior and a social science have nothing to and a social network have nothing to do with those that are studying strategic forecasts for decision making and geographical data. So data-driven decision making companies do not have a single individual doing this. It is a multidisciplinary team formed by people that understand the technological infrastructure, that know how to program, people that understand mathematics and statistics very well. And something that has not been addressed today that is very important is that we are discussing predictive and prospective analysis, which increases the complexity, as well as people that know the field of action of these disciplines. It is not a single person, it is not a single individual, it is a center of excellency, of skills in order to start applying this expertise in different areas. Another question over there. Abel Coronado from INEGI. To Dr. Fabian, could you tell us more about the physical infrastructure with which your analysis you made was done? I did not hear some figures, and I think it would be interesting to know. The cluster that is currently mounted at the High Performance Computing Lab that was recently updated is a cluster of 32 nodes. Each one of these nodes has 2 CPUs, and at the same time each one of them has 8 threads in that regard, and each one of these nodes is also comprises a terabyte of RAM memory and 32 terabytes of hard drive for that purpose. Such a way that we have 32 nodes with 2 CPUs. These are 64 multiplied by 8 threads in that regard. So that is the current capacity we have. This is a relatively small cluster if we compare it, of course, with a supercomputer. But the advantage is that in this case, when we're discussing a cluster of this nature, then it is possible to really work in real time, to have applications in place that could require harnessing the full potential of the cluster for a specific application, as opposed to what would happen in a supercomputer, in which we would only have access to a part of the resources and not even in real time to the full resources that are available. So that is basically the architecture we have in place. The advantage of this type of architecture is that we're only discussing CPUs, but there is also the side of GPUs, of graphic processing units, that are also being used for different types of applications with very successfully. It is very important to highlight that, as we know very well, the location of GPUs as processing elements too is also being widely developed through specific languages for that purpose.